In this lesson, we talk about approximating magnitude. And previously, we spoke about how we can come to the smallest power of 10 that exceeds a number. So, in quick review, if I have a number, let's say 723, I can approximate the magnitude with a power of 10. And we can say that 723 is approximately 10 to the third power. And 10 to the third power definitely exceeds 723 because we know that 723 is smaller than 999. And we know 999 is a little bit smaller than 1,000, which is 10 to the third power. So basically, the rule that we learned is if we count up the number of digits in the number, which is 723, the smallest power of 10, which will exceed 723, is 10 to the third because we have 1, 2, 3 digits. So in this lesson, we come across problems like this. If the radius of Pluto is 737 miles and the radius of Jupiter is 43,221 miles approximately, how many times bigger is Jupiter than Pluto? So just looking at radius, as the radius of Pluto, I can know that 737 is approximately 10 to the third power with 1,000. It's pretty decently close to 1,000. Now, when we use this approximation method for powers of 10, I'm going to end up with 43,221 being close to 10 to the fifth power. But 10 to the fifth power is 1 with 5 zeros after it, which is 100,000. And we know that 43,000 is pretty far off from 100,000. And actually, it would be better to round 43,221 to 10 to the fourth power, because then you're only 30,000 or so off as opposed to 60,000 or 50,000. So it's actually a little bit closer. And then we can take 10 to the fourth and we can divide it by a 10 to the third and we'll get it's approximately 10 times bigger. Those are just quick estimations, and sometimes they come in handy when thinking about how much bigger a number is, and sometimes they're not as useful. But let's look at the next problem. So the average person takes 40,000 breaths in a day. If the average person lives for 80 years, or about 30,000 days, approximately how many breaths does the average person take in a lifetime? So when we want to approximate big numbers, sometimes it helps us to be able to just multiply. These numbers that were given to us are pretty easy to work with, but let's look at the first one, 40,000 breaths per day. I can rewrite 40,000 as 4 times 10, and the 10 part is, if I put the decimal there and made it a 4, you can count the number of spaces over. So it's 1, 2, 3, 4 spaces. So it's 4 times 10 to the fourth. And 30,000 is equal to 3 times 10 to the fourth. So to figure out how many breaths the person takes in a lifetime, we could take 4 times 10 to the fourth. That's how many in a day. And multiply that by 3 times 10 to the fourth. And figure out how many in a lifetime. Now, because of the commutative property and the associative property, we can switch around the order of these and we can come up with, we can multiply 4 times 3 together to give us 12. And from our exponent rules, we've learned that when we multiply exponents that have the same base, then we add the exponent. So 4 plus 4 gives me 8. So in a lifetime, we take 12 times 10 to the 8 breaths. And if we write that number out, we'll get 1, 2, 3, 4, 5,